Hello, let me continue my discussions on inventory planning and management. And this time, let's proceed to the second one, which is the production order quantity. What is production order quantity? Production order quantity can be considered if we have an internal manufacturing that takes place simultaneously with our daily selling activity. And to meet customer demand without delay, it requires keeping on hand some amount of stocks that is awaiting sale. There are three types of cost model that are usually involved in this scenario. I have the ordering and setup cost, holding or carrying cost, and unit production or purchasing cost. It is commonly agreed that ordering or setup cost does not depend on the size of the order cost or lot size of production. And if the product produced is internally, the labor of setting up and shutting down a machine, lubrication, maintenance are included. In contrast, holding and carrying cost is directly associated with the size of production and is often expressed in maybe some in dollars per unit per year. Also included in this cost category are the storage cost, insurance cost, taxes on inventory spoilage, and theft cost. Of course, the obsolescence cost and the opportunity cost of tying up capital inventory seem to be more substantial in this category. I have here the graph. This is the production order quantity model graph. This graph shows that manufacturing could be manufactured more than the demand. I am referring to the daily output versus the daily sales. Say we can produce 8 units per day, but we can only sales at 4 units per day. So this is the graph. Maybe we can produce more than twice of the daily demand. So this is the graph. Say we produce 8 units per day and the demand per daily sales is only 4. So this is the appearance of our graph. So if we are going to optimize the production capacity, we can produce even more than the daily sales. Hope clear up to here. So I have here the production order quantity, which is the POQ. I have the general formula for this. I have Q prime equals the square root of 2 ds over h times 1 minus d over p, wherein we have h holding cost per unit, d annual demand in units, small d daily demand or usage rate, p the daily production rate, s setup or ordering cost per each order. So, still we have the total cost equals setup cost plus holding cost. Okay. And we have for setup cost, it is D over Q times S. And for the holding cost, 1 half H times Q times 1 minus D over P. So, I have here sample problem number 1. Nathan Manufacturing Incorporation makes a sales specially hubcap for the retail automobile aftermarkets. Nathan's forecast for its wire well hubcap is 1,000 units next year with an average of 4 units. However, the company process is most efficient and 8 units per day. He produces 8 per day but uses only 4 per day as the sales. The company wants to solve the optimum number of units per order. Refer below for the detailed information. We have the holding cost per unit, which is $50 per year. Annual demand in units, which is 1,000 units. Daily demand or usage rate, which is 4 units. Daily production rate, 8 units. Sit up or ordering cost per order, which is $10. So, I have here the solution for this problem. We are now looking for the optimum number of units per order. So, using the formula, I have Q prime, which is the square root of 2 times 1,000 times 10 over 0.50 times 1 minus 4 over 8. I use the information given value above, which is stated in the problem. So I have now my Q prime, which is 282 or 283 half cups as the optimum number of units per order. So for its total cost, we have sit up plus holding cost. So I have here the formula for sit up cost, which is D over Q times S, and the holding cost, which is 1/2 H times Q times 1 minus D over P. So here I use the value stated in the problem. Holding cost per year, which is $0.50. Amount, annual demand in 1,000 units. The daily demand or usage rate, we have 4. Daily production rate, 8 units. Sit up cost or ordering cost per order, $10. So, I have this solution. Total cost equals 1,000 over 283 times 10 plus 1/2 of 0.50 times 283 times 1 minus 4 over 8. So, I have my total cost in here, $70.72. So, that is all production quantity. Hope everything is okay up to here. And see you in my next video. Bye-bye, guys.